Hi everyone. So my paper is about the Iceland Plume, which of course is situated under Iceland. However, this wasn't always the case, as Iceland is both a volcanic island and is about 25 million years old. Which is fairly young compared to countries and continents such as Australia, which is some 4,000 million years old. So the birth of this plume. It is believed to have emerged from deep level of the mantle from about 29,000 kilometers below Earth's surface. At this stage, it was hot, solid rock, and it would move up in sort of a mushroom resembling shape. Now, as this moves from the lower boundary of the mantle towards the upper mantle, it experiences reduced pressure and is permitted by the property of partial melting. It moves through the mantle as molten magma, as opposed to just solid rock. By the time it reaches the upper mantle, the melt rises towards the Earth's surface, or in my plume's case, the oceanic crust of the Atlantic Ocean, forming hotspots. Most of the plume remains in the upper mantle, sort of near the area between the upper and lower mantle. So it sits just about there, sort of a third deep throughout the entire mantle, rather than 2/3 deep, sort of near the surface. So approximately 60,000 million years ago, this is when the plume head emerges. So we're at the late Paleocene. So at this stage, it's believed that the plume is about 2,500 kilometers in diameter by the time we reach the early Eocene. Now, at this point in time, the plume is believed to be part of both the Atlantic Ocean as well as Greenland. That's how large it is at this stage. This is also the period where the Eurasian plate and the North American plate begin to diverge from each other, and the formation of Iceland commences here. Now, by the late Oligocene, which is about 20 to 25 million years ago, Iceland is expected to have mostly formed as one of the largest volcanic islands on Earth. Its largest volcano is Katla, I believe, which has erupted most significantly in 1918. In its expulsions of volcanic rock, it ranges from basaltic all the way to rhyolitic. Now, in 930 AD, I can't pronounce what the eruption was named. I've got it on the screen here. But there was a 3 to 8 year eruption duration, and it erupted a very large basaltic flood. And it's measured to be about 800 square kilometers, and also made a 30-kilometer fissure. Very large. And that is one of the reasons why Katla is one of the most dangerous volcanoes in Iceland. Pretty fun. Not really. Now, for my next slide, I've got this beautiful figure. And this is where I would love to introduce my current favorite paper. It is labeled The Deep Earth Origin of the Iceland Plume and Its Effects on Regional Surface Uplift and Subsidence. It is written by N. Barnett Moore, Rakib Hassam, Nicholas Flement, and R. Dietmar Muller, and it can be found in the 8th edition of Solid Earth. So this is actually attributed to the University of Wollongong, even though all the scientists are actually affiliated with the University of Sydney, which is a fun fact I thought I'd share because it made me laugh. So the paper itself was published in 2017, so it is both relevant and recent. So I found it was very good for me to use this particular one rather than one that is from a while ago, because it's going to have more updated references, information. It also provided me with this beautiful, beautiful figure that we can see here. It shows the Iceland plume from 2 different perspectives, which is really, really good. We're able to see that beautiful mushroom shape of the plume, as well as a aerial view if you were in space, without all of the normal Earth in the way. It's such a beautiful figure and is doing a better job than I did when I was looking at G plates. Of course, in my paper I will be using G plates as well as their figure. As mentioned in their paper, the root of the Iceland plume lies near the tip of the African large low shear velocity province. We can see it quite well. It's really, really cool. And now at present, Iceland has about 130 volcanoes, but about 100 of them are actually inactive, which is great. But Katla, the scary one, is still active and has erupted 20 times since Iceland's settlement. Additionally, the Iceland plume is believed to have experienced the stage of mantle upwelling, which we saw during the Eocene, etc. And it is currently at the plume head stage. It has yet to reach the plume tail stage. It might be quite a long time before it does. We could view that quite obviously with Hawaii, as it's got the ... of the islands. It's not really expected to happen, I don't think, because Iceland's currently stationary, despite how active the volcanism is. This is most likely attributed to the fact that it is situated at a convergent plate boundary. So it's got equal pull from both sides. It is quite stable in its situation on the Earth's surface. It's probably not going to move in latitude or longitude. It might grow, and it is growing at a rate of about 1 inch per year, which is pretty cool. And yeah, I think that's all I had for this particular slide, which is awesome. And now on to my beautiful tectonics slide. So I've covered most of the information that we have here, but here's a little recap. So Iceland has that very fun location. As we can see on my little map up there, I've put a nice little yellow circle around Iceland. We can see smack bang on the plate boundary of the green Eurasian plate and the brown North American plate. It is called the Mid-Atlantic Ridge, and it is most definitely an active hotspot here. I actually went on Wikipedia and counted how many eruptions had occurred only the last 1,000 years, and I reached about 150, give or take. There were a lot. Most of them were Katla and I think Ketla. But anyway, it's very volcanically active region, and yet still a lot of people live there, and a lot of people do film and have picnics and everything next to erupting volcanoes. They're just very used to it there. It's very culturally different, but still really cool. There's lots of really cool videos on YouTube as well as TikTok. It's kind of scary seeing people just near erupting lava, like obviously a safety hazard, but you do you, Icelanders, you do you. So I have linked the website that I got this lovely map from. It was from geology.com. I have a little citation slide here, which is pretty cool. I put my paper here. It is a beautiful paper, very well in depth, and it specifically addresses LLSVPs, which is fantastic. I hope you guys weren't too bored of my presentation, and I hope everyone has a fantastic day. Thank you for watching, everybody.